BIM, what it stands for, and how it relates to Autodesk Revit. So BIM stands for Building Information Modeling. And a lot of times when people hear the word BIM, they think of 3D. And while 3D is a core component of BIM, it's not the only thing that makes BIM BIM. So let's break down each one of these words. The first is building. Now, BIM is essentially a model that represents an actual structure, okay? And that can be helpful not only during its construction, but also during the building's life cycle at the end of it when it's actually in use. If you have an accurate 3D model that represents an actual building, you could, if you're, let's say, upgrading the internet capabilities, the AC system down the road, if you have an accurate model that represents an actual structure, it can be easier to choose where stuff needs to get upgraded, where you have available electrical, etc. Now, you can't have a virtual representation of an actual building unless it's intelligent, and that's where the information comes from. The information in BIM speaks to the fact that every element in a BIM model is intelligent and it has information associated with it. So for instance, if you had a door, that door knows that it not only knows that it's, might be glass or wood, etc., it knows factors like who its manufacturer is, lead time to get it to site, if it's hosted on a wall, which wall it's associated with. So if you move the wall down the design process, it actually moves with it. So every element is intelligent, and we'll touch more on that in the next slide. And last, modeling, which relates to the 3D representation of the actual building. So let's go into detail a little bit. So a lot of times when people think of BIM, they also not only just think about 3D, they think of a certain software. And the software that come to people's minds are softwares like Autodesk Revit and Navisworks, as well as Tekla. Now, these are merely tools to help you achieve BIM. None of them are equal to BIM. Because, like I mentioned, the BIM is a virtual model that represents an actual structure, and these tools just help you achieve that, but they're not equal or interchangeable. So in this case, I'm bringing up the door example again. You can see that when you select this element, the door, you have all these different properties, which can relate, I mentioned before, can relate to cost, materials, the options for them. So if you have different, materials that can be used for them, different locking methods, etc., and also the requirements for them, they can be listed in these properties. And the power of this is because a BIM model, by its very nature, can be adjusted and tweaked during the design process, and then ultimately when it gets built, you can reach into it and pull information about certain elements. The true power of it is when you use this information embedded in all these elements to create schedules, analyze them, etc. So, what else can BIM be used for? Well, we already touched on the 3D visualization aspect of it, but because of the power and intelligence of all these components inside of them, or the information, you can use the information embedded in these elements to create time and schedule during the construction phase. So if you want to coordinate your trades, such as electrical, HVAC, concrete, etc., you can use the information embedded in the elements to figure out when the best time to schedule the different trades, as well as how much time it's going to take to install them. And then ultimately, all this information, because you're dealing with time, we all know time equals money, and you can do a 5D analysis of your structure to see the cost that it's actually going to cost to actually build a building, and then also how to maintain it in the future, like I said, relating to cooling efficiency and heating efficiencies in the future. So that's a kind of a top level of what BIM means, and now we're going to get into the software in Revit and how to use it to achieve BIM.